Okay, so we just talked about factoring, so let's talk about some special factoring situations that kind of arise from special multiplication situations. So remember, if you multiply conjugates, that was something like x plus 3 times x minus 3, the middle term disappears. That makes it kind of weird looking for factoring. So when you see perfect squares with a subtraction in the middle of them, we call that the difference of squares. There's an alternate way you can do this by just writing a 0 of the middle term. It only works for a minus sign in the middle. It does not work for a plus because you need the two numbers to multiply to a negative because one needs to be positive and one needs to be negative. So for x squared minus 25, there are two ways to do this. You either call it x squared plus 0x minus 25 and do it normally. You're just looking for two numbers that add to 0. Or you see this is a perfect square. It's 5 squared. This is perfect squared. It's x squared. And there's a minus in the middle. And the pattern is that therefore it's x minus 5 times x plus 5. These two will make the middle terms cancel out. So this will only work if it's perfect squares. And it only works if there's a minus in the middle. So y squared minus 49, again, this is 7 squared, so this is y plus 7 times y minus 7. And if you don't like the pattern, always feel free to use the technique where you write the 0 in the middle and factor normally. Now a squared plus 81, this is a squared plus 9 squared. Well, those are two squares that are, so it must work, right? It's a plus, so they must just both be plus signs. Wrong. If you have a plus between two perfect squares, it doesn't mean anything. This can't be factored. It's already in the most factored form it can have. K squared minus 18. Even though this is a perfect square, this is not a perfect square, which means this can't be factored either. So keep that in mind. J squared minus 9g squared, even though there's two factors, this is j squared. This is 3g squared, because 3g times 3g is 9 squared. So this whole thing is j minus 3g and j plus 3g. I'm going to leave number 6 for you to do, because it's like 5. I'm going to leave you number 7 because it's easier, and we'll talk about number 16. 16z to the 4th minus 625. These are both perfect squares. This is 4z squared squared minus 25 squared, which gives me 4z squared minus 25 and 4z squared plus 25. You might think you're done there, but look at this thing. It's another perfect square. This is 2z squared minus 5 squared. So this thing factors again into 2z minus 5 times 2z plus 5. 2's and z's in the same problem is a poor choice, but that's okay. This one is a positive in the middle, so it can't factor again. Times 4z squared plus 25. So sometimes you can factor it once by difference of squares, and one of your terms will factor again by difference of squares. Now, in addition to difference of squares, we have perfect squares. Sometimes it's the same thing twice. Now, how do we know when that happens? Usually you can identify it when the last digit is a perfect square, and whatever the square root of that is, the middle term is double that. Now, nothing's actually stopping you from factoring this normally. I would actually almost always factor this normally. So if I'm factoring it normally, I'm looking for the factors of 25 that add to 10. I'm just going to look at that as 5 and 5. Say, well, this is x plus 5 times x plus 5. But that's the same thing as x plus 5 squared, because it's the same thing twice. So all they're saying is that you can do it this way. If you recognize this number, what's the square root of 16? It's 4. If this is double 4, which it is, then you have a perfect square. And the sign comes with it, and it's whatever it is cut in half squared. I don't think that's that easy for most people to remember, but if you want to try it, go ahead. I think you're more likely, though, to mess it up. Now, the only way this works, what's the square root of 81? 9, but this needs to be double the 9. If it's not double the 9, it's not a perfect square. So this one's actually not factorable. It needed to be an 18 and not a 9. Furthermore, this has to be the third digit has to be a plus, because it needs to be negative times negative or positive times positive for it to be the same thing twice. So this one is also not factorable. So the things you have to have are a plus in front of the constant, and the square root of this thing needs to be doubled in the middle. I would generally, though, recommend that you do it an alternate way. Just factor normally if you're not comfortable. Let's talk about these ones with fractions, though. It can be a little harder. If you don't see the pattern, you might say, well, this is kind of hard. There's a way around the fraction, though. I'm going to multiply everything by 25 over 25. Now what's going to happen here is 25 times 4 is 100p squared. The 25s will cancel here. I'm going to write it minus 9. Put the whole thing over 25. So this is an alternate way to do it. When I factor this, this is perfect squares. So this would be 10p plus 3 and 10p minus 3 all over 25. Now what do we know about 25? It's 5 times 5. So I can make this 10p plus 3 over 5 times 10p minus 3 over 5. And I can clean it up from there. Make this 10 divided by 5 is 2, so 2p plus 3/5 and 2p minus 3/5. So if you don't see the pattern and you don't see that 9/25 is 3/5 squared, you may not. There is a way around it by clearing the fractions. You just can't entirely get rid of the fractions. So I'll leave number 8 for you to practice. The last special pattern, which we will revisit again in college algebra when we get there, is called the sum and difference of cubes. It has a special formula. So let's talk about factoring cubic functions. Both of these things need to be perfect cubes. So x cubed is a perfect cube. It's x cubed. 8 is a perfect cubed. It's 2 cubed. Now there's this formula up here, which you're just going to have to know. If there's a plus in the middle of them, there's the sum of cubes formula. A is x here. In this case, it's the first thing cubed. B is 2. And I just plug it into the formula. 8 plus b is x plus 2 times a squared minus ab plus b squared. So a squared will be x squared minus ab, so minus 2 times x, plus b squared plus 4. This is just something you're going to have to practice. There's a different formula for the minus in the middle. I want to do one more that's a little bit tricky. That's a minus in the middle, doing number 6. Sometimes you have a common factor. So what do 5x to the 8th and 40x squared y to the 9th share? They share a 5 and an x squared, and they leave x to the 6th minus 8y to the 9th. Now the inside here is a perfect, both of these are perfect cubes. This is x squared cubed, and this is 2y cubed cubed. So this goes into my a and b. So a is x squared, b is 2y cubed. The 5x squared is just going to come down. So we have 5x squared. There's a minus sign in the middle, so we're going to use the difference formula. So a minus b, so x squared minus 2y cubed, times a squared, so that's x squared squared, plus ab, so plus x squared times 2y cubed, plus b squared, which is 2y cubed squared. I'm running out of page. Okay, so this is 5x squared times x squared minus 2y cubed. Let's clean up the last term. That's x to the 4th plus 2x squared y cubed plus 4y to the 6th. And these are all the special cases. We'll do 5.5 in the next video.